The success of every business is determined by what's left after all operating costs have been paid. If there is little or no profit for an extended period, the business will cease to exist, or at best, a new owner or manager will assume leadership. Farming is no exception. Most managers agree that except for timing of sales, there are two ways to improve the profit situation of a business: cutting operating costs or increasing production or output. This presentation was prepared to tell you how farmers who irrigate can do both, with a program developed to help farmers who grow crops use irrigation water more effectively, protect the environment, and improve their net returns. Midwest farmers who use the Soil Conservation Service's Irrigation Scheduler program have used 10 to 15% less irrigation water each season, and on average harvested about 7% better yields. Stated another way, they eliminated the cost of unnecessary irrigation and they had more crops to sell. Irrigation Scheduler is a computer-assisted management aid that helps farmers apply the right amount of water at the right time for effective, efficient irrigation. It can be used any place in the nation or the world. All that's needed is data about the crop grown, soils in the field, and daily climatic changes. Care was taken to be sure the program could be used by farmers, consultants, and other irrigation decision makers on readily available computer equipment, and the data was presented in an understandable format. It utilizes available weather data to project irrigation needs. It works best, however, when there is access to current weather data for the field or the farm. Although it's designed to automatically access and retrieve data from a weather station, needed climatic data can be entered manually. It's a program farmers who irrigate their crops need to use limited water supplies more effectively, to reduce time for effective scheduling decisions, to decrease the potential for water pollution, to cut energy consumption, and to improve net returns. Once the program is set up for a farm, the only inputs needed for accurate summaries of water use and need are the time and amount of rain or irrigation. These are balanced with the crop's estimated water use, similar to the way a checkbook is balanced. The program maintains databases for soil, crop, and climate specific for each field or operating unit. Using these databases and current weather data, Irrigation Scheduler predicts when drought stress will occur and indicates when a specific amount of water needs to be applied for optimum growth. To plan an effective irrigation system, it's critical to understand how crops grow and when they need water, what happens to water that falls on a field, and how much water is available in the soil. Most people associate irrigation with arid regions and might ask why farmers irrigate crops in regions with enough rain to grow crops. Understanding the soil-plant-water relationship helps one understand why an increasing number of farmers in humid or subhumid regions irrigate crops for optimum production. A crop's water need and growth are directly related. The growth period for corn, used in this example, is about 120 days. The curve turns upward about 40 days into the growth cycle, indicating rapid growth and high water need, and continues through the tassel and dent stages. For corn, the highest and most critical water need is between the tassel and dent stages, which begin around the middle of July. During a typical year, however, a crop's water need often does not match natural rainfall. Comparing this graph with the previous one explains why yield potentials were not achieved. Anytime a crop's need is not met by natural precipitation, crop quality and yield are reduced unless needed water is provided. Rains that occur during the high demand period often occur with such intensity there is little opportunity for the water to be absorbed into the soil. Consequently, it's important that the operator adjusts for runoff and provides the program with only the amount that is absorbed by the soil. Not all the irrigation water we apply or rain we receive can be used by the crop. Evaporation and deep percolation reduce the water that's actually available to crops. These losses may occur before crops have an opportunity to use the water or are part of normal irrigation operations. Irrigation Scheduler automatically takes them into consideration. The soil is a reservoir for plant water. All soils have different available water capacities. Sandy soils have low capacities, while clay soils have high capacities. This too is considered by the program when making an irrigation schedule. An adequate supply of water at the right time is the key to a positive crop response and may be the difference between successful and unsuccessful seasons. Many farmers have long recognized the value of supplemental irrigation, but until recently had to rely on intuition, tradition, and luck to manage their irrigation. Experienced irrigators also acknowledge that when they can see the early signs of moisture stress, it may already be late to begin irrigating. Irrigation Scheduler, using existing and historic weather, crop growth, and soils data, can project the amount of soil moisture for up to 14 days. This projection allows Scheduler to indicate when a specific amount of water will be needed to keep the soil moisture level within safe parameters for the crop being grown. For accurate projections and irrigation schedules, the computer must have information from the farmer about rain and irrigation since the last schedule was prepared. Occasional soil moisture checks are compared with the program's projected moisture levels to calibrate the program. This process also strengthens confidence in the predictions. A cumulative summary of water input and soil moisture levels is part of each scheduling report. Actual irrigation and rain inputs are shown across the bottom of the graph. This allows the operator to compare calculated or projected soil moisture levels with crop responses and minimum and maximum safe moisture levels. It also provides objective data for management decisions in successive seasons. It may become apparent from the summary that the first irrigation was too late and that the deficiency caused by the delay continued throughout the season. That too much water early in the season limited development of deep root systems needed to support plants later in the season. Or that irrigation late in the crop's growth cycle was not necessary because water stored in the soil was more than sufficient for the maturing crop. As long as the computer is updated regularly with current weather data, it knows the current water needs of the crop, the amount available to the crop, and can predict quite accurately when drought stress will occur if additional moisture is not provided via rain or irrigation. The Soil Conservation Service's Irrigation Scheduler program has evolved into a comprehensive irrigation aid that is helping growers reduce energy consumption, reduce runoff and erosion, prevent water contamination, and improve profits. Local soil, climate, and crop information adapts the program for any location. And farmers or their consultants can use it on readily available computer equipment. Irrigation Scheduler is a logical program that makes sense to farmers.